This question is a sine rule question involving bounds or limits. It's taken from the Corbettmaths worksheet Sine Rule, the apply section. And it also requires a knowledge of the different values that sine of an angle can take and what happens when the angle increases and decreases. So knowledge of the sine curve is essential to answer the question. So here we have a triangle ABC. It's labelled with the two angles on one side, and all values are correct to two significant figures. And we're asked to find the upper bound of length AC. So that's this side here. We're going to call that little b. I'm calling it little b because it's opposite the angle B. So I have a matching pair here, so that's great, and you need that for the sine rule. We've got a matching pair here, we've got a matching pair there. So we know what we're going to have here is b over sine b equals a over sine a. Now I'm writing it in this form rather than putting the number straight in because it's a question involving limits. If I rearrange this, I'm going to get b equals a sine b divided by sine of a. Now, I want the upper bound, so I want this fraction to be the largest thing possible. So for that to be the largest possible, for the b to be the upper bound, the upper value, okay, I'm going to need the largest thing on the top of the fraction divided by the smallest thing on the bottom. So I'm going to want the upper value of a, the upper value of sine b, and I'm going to want the lower value of sine a. And it's not as straightforward as you might initially think. So looking at the limits, looking at the bounds, for angle A is 25 degrees. The upper limit for that would be 25.5 degrees because it's to two significant figures, and the lower bound, let's remove that, lower bound is 24.5 degrees. Angle B is 140 degrees, again to two significant figures, so the upper bound will be 145 and the lower bound 135. And then for the side A, which is 14 centimeters, the upper bound for that will be 14.5 centimeters and the lower bound will be 13.5 centimeters. But we're dealing with angles here, so let's just have a look at this. If you had we're going to have the sine of these angles. So what is the sine of 25.5? Sine of 25.5 is 0.43. What's the sine of 24.4? 24.5 rather. 24.5 is 0.41. So that makes sense. The lower bound is 0.41, the upper bound is 0.43. Now let's go on to angle B. What's the sine of 145 degrees? Well, that equals 0.57. And what is the sine of 135 degrees? That is 0.71. It's larger. It's the sine of 135 is larger than the sine of 145. Now you can see that on the graph. We have 145 degrees, it's going to be somewhere about here, and that's going to give me a value there. On the left-hand side of that, my value is higher. So if the angle is more than 90, you've got to be really careful which one you're going to choose to be the higher value, because the larger the angle, between 90 and 180, the smaller the value of sine. Now let's go back to my equation. I want A upper, sine B upper, and sine A lower. So which ones do I want? I want A upper, which is the largest value for little a, that's 14.5. Which is the sine B upper, the largest one for sine B is 0.71. And I want sine A lower, and the lower value for that is 0.41. So for my B upper, my upper bound for B, I want A upper, which is 14.5, multiplied by sine B upper, which is sine of 135. I'm going to go for that because that'll give me the most precise answer I can get. and I want to divide it by the sine A lower, so that's sine of 24.5. And when I put that into my calculator, I get the results of 24.72. And because my numbers are to two significant figures, maybe I want to round that, and I'm going to say that is then 25 centimeters. But just to check, I would make sure I write both figures down, just depending on which way the examiner wants to see the answer.